So I like to look at these from a graphing perspective as well. Just instead of just saying here's the derivatives, we can look at kind of why they are what they are. So this graph is not going to have any critical points. It never quite flattens out here. It is increasing all the time. So the derivative will always be positive or above sea level. And if I draw in tangent lines, they start out with very, very shallow slopes, like almost zero, and then get steeper and steeper and steeper and steeper. So if we draw in that derivative, it's going to start out really, really close to zero and then go up and up and up and up and up. So e to the x is its own derivative. And again, I'm just going to keep a little list off to the side here. I recommend making flashcards or writing them down at some point. But derivative of e to the x is e to the x, which is great. That's like the easiest one. Now, it doesn't come up real often. And when I say not real often, I mean pretty much almost never. But technically is part of the material, so it's fair game for the AP exam, so I don't want to not go over it. Instead of e to the x, say it was some other number, like a to the x. That would be like 2 to the x or 7 to the x. Like if there was some other number there, that would still just be itself, but then you have to multiply on ln of whatever that number was. So like if this was a 4, you would multiply on ln of 4. So it's just like that one other step. They may throw a multiple choice one like that at you on the AP exam. So I'm gonna make sure I go over it. All right, for ln of x, this is again increasing all the time, so its derivative will always be positive. And if I draw in tangent lines, they have very, very steep slopes, and then they kind of start to level off and go almost down to zero, but not quite. So if I draw that over here, I'm going to start out really, really high up and then come almost down to zero, but not quite. So what is this the graph of? It's a little tricky because we actually only got part of the graph. But what function is this that we've ended up with?
Isn't it like half of irrational or
Yes,
something?
good. If I had drawn in this part down here, I think you guys could see it. The reason that we don't get that part of it is because ln only has a domain that's positive numbers, so we don't get that piece of it, but it is the rational graph. So derivative of ln of x is 1 over x. And again, it does not come up often, but it's technically fair game, so I just want to make sure I've covered it. Instead of ln, if you had log with a different base, like log base 3 of x or log base 9 of x or something else, it would still be 1 over x, but you're going to multiply on 1 over ln of a. So I know it's just like one more thing to remember. Again, I wouldn't overly stress about this. The likelihood of it coming up is small, but it's there, so I just want to make sure that I've gone over it for you. So now we're going to just go do a bunch of examples. So derivative of 3e to the x. Well, derivative of e to the x is e to the x. The 3 is sort of just there as a coefficient. That is itself. E to the x is the greatest function. It's like my favorite. That's just the easiest one to deal with. What rule, and you can either answer or type it in the chat, but what rule are we going to need for this derivative?
Product rule.
All right, perfect. Product rule. This is going to be the first thing. This is going to be the second. So product rule is the first. Derivative of the second, well, that just is e to the x, plus the second, and then derivative of the first would be 2x. I know I haven't been simplifying really any of these. I'm not overly worried about it, but this one, you know what, let's go ahead and factor this one because these terms have so much in common. This is the first term and this is the second term. What do they share that we could factor out of each of them?
E to the x.
Good, we've got e to the x and something else. What else can we take? We can take out the e to the x.
And 1x.
And 1x. All right, so if we take out x e to the x, this just looks like I've forgotten how to spell or something. You will be left with x plus 2. All right, so this one is a chain rule. Derivative of the outside function would be the e part. Derivative of the inside function is the 4x squared. So derivative of e is itself. So I'm basically just going to copy this down. And then I'm going to chain on the derivative of that stuff, which would be 8x. All right, and then this one is a quotient rule. So that is going to be the denominator times derivative of the numerator minus numerator derivative of the denominator. This is a chain rule. So it will be itself, e to the 5x, and then you have to chain on the derivative of 5x, which would be 5. And then it is over the denominator squared. I'm going to go ahead and just write it twice. Because since e is its own derivative, we got a lot of repetition here. Do you see how we have an e to the 5x in this term and an e to the 5x in this term? We have it in both places. If we were to factor that out, we would then be able to cancel it with one of these. So one of the e to the 5x's is going to cancel. So this would be 2 minus, I'm going to have to distribute, well, actually, let me think of it as distributing a negative 5 through these parentheses. We're going to distribute the negative and the 5. That would be minus 10x minus 5, and then over e to the 5x. And then actually the 2 minus 5 would be negative 3. Sorry, my brain kind of shut off on me for a second. All right, so here's an example of one that has a base that is not e. It starts out the same, it's just going to be itself. And then we're going to chain on the derivative of that inside part. Derivative of x squared would be 2x. And then you just have to multiply on an ln of 7 for the end of it. And that is just part of the rule there. All right, number 6. Derivative of ln would be 1 over x. There just kind of happens to be a 4 hanging out there, so it would be 4 over x. This one would be another product rule. So we've got the first thing, the 2x cubed. Derivative of the second would be 1 over x plus the second thing, and then derivative of the first would be 6x squared. I am going to clean this up a little bit because one of these x's is going to cancel. So that'll be 2x squared plus all the rest of this. This one is a chain rule. It's like ln got hungry and ate all of this stuff. Ln is the outside function and all of this is the inside stuff. So derivative of ln is 1 over x, but for this chain rule problem, it's going to be 1 over whatever you've got. It's just that stuff. If there's more than just x there, it's all of that stuff. And then we're going to chain on the derivative of that stuff. Instead of writing it off to the side, I'm just going to go ahead and put it in the numerator. So the derivative of all this will be 10x minus 3. Here is another quotient rule. That is going to be the denominator. Oh, this one has trig in it too. Denominator and then derivative of the numerator. Again, this is a chain rule. Outside function first. Derivative of ln is 1 over whatever you've got there. And then we need to chain on the derivative of 2x, which would just be 2. So actually those 2's would cancel as well. So that's denominator, derivative of the numerator, minus the numerator times derivative of the denominator. And derivative of sine is cosine. And then it is over denominator squared. Right, and so this one, again, I don't think this is going to come up a lot, but let's just do one example of it. It's a not a natural log. It's a log function that's not natural log. We have a base of 3 instead of a base of e. So it's going to start out the same. You'll have 1 over whatever you've got there. And then we're going to chain on the derivative of that stuff. I'm just going to put it in the numerator. So the derivative of 10x squared would be 20x. And then we have to multiply on 1 over ln of whatever the base was, which in this case is 3. So just to kind of clean that up a little bit and make that look better, this is going to reduce to 2, and one of the x's is going to cancel. So this will be 2 over x, and then the ln of 3 is also in the denominator. All right, so this is a chain rule that again has 3 links in the chain. The cubed is the most outside function, then the cotangent, and then the e to the x. So first the power rule. The 3 is going to come down. It's going to drop to a 2. Everything else stays the same. So we're kind of done with that. So ignore the 3 now. So now derivative of cotangent. It's a co, so I know it's negative. And derivative of cotangent is negative cosecant squared. And again, the inside part just comes along for the ride. It's just still e to the x. And then third link in the chain, we're going to chain on the derivative of e to the x, which just is e to the x. And again, this is all one term. It's all just being multiplied together. This is another one that has 3 links in the chain. We're going to start with the most outside, which is secant, and then ln, and then 4x. So derivative of secant is secant tangent. It's going to be secant of all this stuff, tangent of all this stuff. All the guts of the problem has to stay the same. So it's secant of all of that, tangent of all of that. I am going to run out of room. Well, maybe not. The rest of this will be shorter. And then chain on the derivative of ln, which is going to be 1 over whatever you've got. And then chain on the derivative of 4x, which would just be 4. And then actually the 4's would cancel. And you could write the x in the denominator. That would look better. It would be all of this stuff over x. Let me fix that. That'll look a lot nicer. All right, this one looks like a total disaster. It's ln of all of this. So you would have derivative of the outside part, and then in here you'd have a quotient rule. This part would be a product rule and involve a square root. That is just a mess, and you don't want to go about this problem that way. Before I do the derivative, notice I'm not putting a prime here. I'm just going to rewrite the function in a better way. Every time I bring up log properties in calculus, everyone's like just staring at me. They are true. You did learn them back in pre-calc. We'll see what you remember. Anything in the numerator is going to be positive. Anything in the denominator is going to be negative. It'll get subtracted. And then you are allowed to take these powers and write them out front. I feel like I mentioned that once this year. Everyone's just kind of like, yeah, I sort of remember that. So for the x squared, I can rewrite that as 2 ln x. And then for the square root, the power for a square root is a 1/2, and we're allowed to bring the power out front. So it will be 1/2 ln x minus 1. And then the denominator doesn't have a power at all. It's just 3x plus 4. So we don't have to worry about bringing a power out front, but this will be negative since it's in the denominator. So minus ln 3x plus 4. And then you're like, how did that make it better, Miss Cole? Because we can do it as 3 totally separate problems. So we've broken it into bite-sized pieces. We can do just this part, and then just this part, and then just this part. So it breaks it into something that's more manageable. So for the first term, derivative of ln is 1 over x. In this case, it's just going to be 2 over x, since we have a 2 there. Plus, again, this derivative would be 1 over whatever you've got. We just happen to have a 2 in the denominator as well. Now there is a chain rule here. We would have to chain on the derivative of this stuff. But what is the derivative of x minus 1?
1.
Yeah, that would just be 1. Because it's 1x to the 1, so that would just be 1, and then this is a constant, so it's going to go away. So I'm not going to write times 1. So there was a chain rule, it's just, it was 1. All right, minus, and then this is going to be 1 over all this stuff, and then we have to chain on the derivative of this stuff, which I'm just going to go ahead and put in the numerator, and that would be 3. These 3's can't cancel because I've got this 4 here. All right, and then last one, another equation. All right, what are the 2 things we need in order to write an equation?
Point and a slope.
Awesome, thank you. Point and slope. I always just write it like that, like blank, to remind myself of what all I need. Our point is going to be at e squared. So to get the y value for the point, I'm just going to plug in e squared. So e squared to the 3rd, e squared cubed. When you do a power to a power, you multiply. So that would be e to the 6th. And then ln of e squared. Ln and e cancel. And that will literally just give you 2. Or you can think of it as being able to bring that 2 down and write it out front. But either way, this is going to be 2e to the 6th. I always like problems that look really like intimidating like this. And like the most math we did was 2 times 3. You know, it looks really intimidating, but it isn't. All right, slope comes from derivative. This is going to be a product rule. So first thing times derivative of the second plus the second thing, and then derivative of the first. So this first term is really just going to be x squared. I'm going to go ahead and just rewrite it. Because that only took me a few seconds, and this just looks a lot nicer. So we're going to plug in our x value to that. So we're going to plug in e squared. So for this first part, e squared squared will be e to the 4th plus ln of e squared. Once again, the ln and the e are going to cancel. So this coefficient is just going to be 2. And then I've got 3 e squared squared, which again would be e to the 4th. So this is 1e to the 4th. And then here I've got 2 times 3 would be 6e to the 4th. So adding them together will be 7e to the 4th. And so this is our point, this is our slope, and we're just going to put it together to write the equation. So y minus my y value equals the slope, and then x minus the x value.